Thanks, Nicole. Appreciate it. Thanks for everybody sticking with us here. Always a pleasure to come hang out with everybody and have some fun. And I get to kick off here and try to show you guys a bit of some what I feel are efficiency tools and things in Niagara to help you with projects, particularly on enterprise type things. So managing Niagara at scale. We're going to talk a little bit about data modeling and some system database and things like that. So I was trying to, play along here with the theme, and I felt like because I'm a technology guy and I like camping, I would have been building like a pillow fort in the house with my Jace and all that kind of stuff, maybe doing some old school Nintendo games and stuff like that, but just trying to have a little fun here for a second. But what we want to talk about real quickly, and half hour is not a whole lot of time, I think, so Nicole or whoever, feel free to do the Looney Tunes thing with the cane and yank me off stage if I'm running long here or something. But I want to talk about the value of data modeling a little bit, what the value proposition is, and just kind of mention component and device templates a little bit. I do have some in some stations that I'm running here, and I think a couple of the other presenters are going to sort of fill in the gap there a little bit. Bobby Palmer and Charles Johnson probably talk a little bit more about templates and different ways of deploying some things quickly. So I'm going to focus a little bit more talking about virtual on-demand PX as opposed to using export tags like PX view tags and that sort of thing. And talk a little bit about the NSpace ORD scheme as well, in case you haven't seen that before. It's something that's pretty useful to use, and we'll kind of wrap up talking about system database and then some hierarchies, all right? So don't really want to do death by PowerPoint here, but a couple slides just to kind of talk through some concepts, and then I'll shift over to Workbench and show you some examples, right? If you're not doing data modeling today, I would strongly suggest that you start looking into that. And when you look at things like ASHRAE 223P, you look at what's going on with Brick and Haystack and other ontologies, it's just becoming more and more of an expectation that your application has some extra metadata associated with it, right? And there's different ways that you can go about doing that from a efficiency, flexibility standpoint. One way is if you have your station, you can use the batch editor and you can bulk assign tags to things, right? So that's an efficiency way of getting some data modeling applied. Another approach is to use component and device templates and actually put direct tags on things in those templates. So whenever you deploy them, they already have the data model assigned. Or if you have some Java experience, then using program objects and things like that to do batch manipulation of tags is an easy way to go about it. So we give you a lot of different ways that you can apply a data model, and it's very important, I feel like, that you do. The value proposition to that is that it's providing plumbing, right, that's going to help with a lot of other things, like hierarchies that provide dynamic navigation, that also serve as history groupings, and I'm going to try to show you guys what I mean by that. It's easier to build a hierarchy than it is to apply all the tags to the history config and do a history grouping, for example. If you're doing component templates, device templates, tags and relations become important typically in deploying those. And then getting into things like tag-based PX, because you can do a lot of cool things with relations and tags using that data model that you can't do with just slot-based, relative ORDs and absolute ORDs in a PX view. So it kind of unlocks the next level on your UI, UX design with your graphics. And of course, things like fault detection, whether you're using Niagara Analytics or not, then the data model becomes very important, okay? How many of you are using component or device templates today, just by a show of hands? Okay, maybe a quarter of people maybe. And who's applying a data model, doing any kind of tagging? Whew, not very many people, right? When we talk about component and device templates, the reason why you want to use those is because a few reasons. One, it's going to reduce your engineering labor. And two, it's going to help you establish standards within your own company or within multiple companies that might be servicing the same customer, right? If you have like a big university, K through 12 or something where there's multiple contractors that put things in, using component and device templates will enable that customer to enforce a standard across those different vendors, or within your own organization enforcing a standard. So everybody does things the same way. The wire sheets are laid out the same way. It's easy easy to troubleshoot. If someone's sick or someone's out on vacation, you don't have to go and reinvent the wheel and figure out what they were doing on a job, right? So that's kind of the reason why I feel like using those, and I think Bobby in particular is going to show you a little bit more about it, and maybe Charles was going to show a little something maybe about that as well, okay? How many of you use PXView tags or point tags on jobs? So a bigger percentage of people, that's good to know. If you are doing a server-centric job where you need proxy points, I would certainly say that doing point tags is absolutely the best way to do it, right? It's gonna eliminate fat finger errors, it's gonna be consistent, the quickest, most efficient way for you to build out those proxy points in the supervisor. If you don't need those server-centric proxy points, then looking at the on-demand virtual PX is, I feel like, really the way to go. It's simpler than doing the PXView tags, and there's some flexibility in it. I'm going to try to focus more on that here when I shift over to Workbench and focus about some of the end space ORD schemes and station schemes, okay? Then the other thing, and again, we'll show you this in the Workbench, but there's an ORD scheme that we introduced, I think in 4.4 maybe, that's called end space, and it's essentially a substitution for the station ORD scheme. What I'm trying to show you on the slide there, under the local station examples, you can see where it says end space, colon, pipe, and then slot, colon, home. That's equivalent to station, colon, and the same slot path. So if I'm navigating inside of the same station, then it's gonna be an equivalent ORD for me, okay? Where it can pay off, though, is when we start looking at remote stations, and it does like an ORD substitution for us. And instead of it pointing to that thing in the remote station, it'll point to the equivalent path in maybe the supervisor station. So if you're familiar with PXView tags and using the substitute override ORDs, this is a way that you can design your PX page to handle those redirections to keep you like in the supervisor, for example, instead of actually linking down to something in the remote station through the virtuals, right? I'll also get into a little bit more depth here talking about system database. Any of you using SystemDB today? Okay, 1, 2 people. So what system database is a no graph or no SQL database. It's a graph database that runs at the supervisor and is used to index all the information about your stations across the enterprise. It'll know about the drivers, the devices, the points, the things with PX views and all that sort of things in the station. Plus it knows about the tags that are on them and the relations that are between them and things of that nature. So it allows us to do things like enterprise-wide reporting, enterprise-wide hierarchies and things of that nature. So it's definitely critical when you're working on larger jobs that you want to have an enterprise type system, right, is to utilize that system database. And starting in 4.13, we added support for multi-tiered system database. So what I mean by that is in that sort of little infographic in the bottom right corner, it's trying to say, hey, I have this campus supervisor and it only communicates to a supervisor in each of the buildings maybe. And then that building supervisor communicates to JACEs underneath it. So it's more than one tier. The system database can index things all the way down to the edge up into that central supervisor. So it allows us to know about everything, even if I don't have a direct connection without going through the virtual space, right? And then the last thing we're going to kind of focus on is hierarchies. And if you're not using hierarchies today, I would really suggest that you do. And I'm going to try to illustrate to you why I think you should be here in just a second. But they're more flexible than nav files. They're dynamic. And they're also a great replacement for like history shortcuts and doing history groupings, right? And they're a lot more flexible than history groupings, okay? So get out of the PowerPoint here and we'll jump over to Workbench actually. And in this case, I have a supervisor station running on my PC and it's talking to a couple of JACE stations in the back of the room there. And in this case, hopefully you guys can see that on the screen okay. Looking under the Niagara network here, can you guys in the back see okay? Can you kind of read? Good? Okay. So you can see under the Niagara network of my supervisor, I'm only talking to this building 100 station, but when I go look at the building 100 station at its Niagara network, then it's going to be communicating with that supervisor, but it's also communicating with another building, okay? So my campus supervisor doesn't have a direct path to that, but we can get to it through the Niagara virtuals of the other station. So that's one of the key aspects of that multi-tiered system database, and also the multi-tier on the security dashboard as well, okay? Now, as far as templates go, and for those of you that might not know what templates are, perhaps what a template is a reusable piece of code, right? It includes the component, which in this case is a LAN device, and it has all the points already mapped in it, and it has history extensions, alarm extensions already set up in it, already has graphics included. And we have version control associated with this, right? So there's a version number that's there, and when we make changes, then we can add more comments to it. We can keep old versions of our template. And what this allows us to do is, if I've got 100 VAVs or 100 air handlers or whatever in a station, and I need to make a change to them, if I've deployed them with a template, all I have to do is go modify that template, and then I go into the station and I redeploy or upgrade it. And that'll make that change across all the devices that exist in the station. So it's an engineering efficiency thing. I don't need to go to 100 wire sheets and go make the same changes. I make the change one time in the template, and then I tell it to upgrade the template. So it's an efficiency thing as well as a standardization thing, right? Because it keeps all the components and all the wire sheets in exactly the same places, right? All the components are named the same way. Everything's consistent across all the instances of this thing that are a template, okay? So I'm not going to get into the weeds about how to do all that, but conceptually, that's the idea, and I think Bobby will show you a little bit more in the details about it. So when for example, in my Building 100 station here, if I go look at the template service, we'll see that all of my LAN devices will be listed here, and they're all been deployed using this template. And I can see what version they're deployed with. I know that it's up to date with what I have. Again, if I make a change, I go modify the template, set it as a new version. When I come in here, I would have an opportunity to upgrade all those to that new version. Or I could downgrade them back to the previous version if whatever my change was, caused a problem, okay? So that's a critical piece, I feel like, to efficiencies as you're working with BACnet devices and LAN devices, particularly across jobs that have scale, okay? Now, I'm not going to get into the weeds on how to apply a data model. That's something that we could spend a lot of time talking about, but just suffice it to say is that I do have a data model applied to my application. And I'm using both the Niagara data model or the Niagara tag dictionary as well as the Haystack tag dictionary to apply a data model. And once we have that data model applied, then we can build things to help with our navigation, right? So looking in I'm going to go into this Building 100 station here, and there's something called the hierarchy service. If you guys aren't familiar with this, hierarchies are a way to build navigation for the station, and it's all based essentially on the data model. So looking at maybe a quick cheat sheet here, we can see that just a real quick high-level kind of explanation, right, is that I have my components in the station, and they're going to have some extra metadata assigned to them, right? It's going to be things that are saying, hey, this is a floor in the building, or what floor number is it? This thing is an air handler, or it's a piece of equipment, or what kind of data point is this, right? We're going to have some data model applied to that. And with the Niagara dictionary, you get some free relations that come along that you don't have to even configure. Things like parent and child relations that exist between the things in the station. We also have some automagic relations that show up between things like networks and devices and points and things of that nature. So even if you don't do anything to apply a data model to a station, just the fact that the Niagara dictionary is there is some data model applied to the station. Now, it's not a Haystack data model or a brick data model, but there is a data model applied. There are implied tags like what type of component it is, what the name of it is, who its parent is, who its child is, what the driver is, or the device that the point's under, things like that. So a lot of people, I hear people say data modeling is difficult. It's not really difficult, to be honest. And we give you some basic data model to start with. Now, if you want to apply a haystack data model, brick data model, things like that, yes, there's more effort involved, right? But I'll also be the first person to say you don't need to data model everything in the application either. I think you need to think about critical things like, what do I want to display in a graphic, or what do I want to be able to do fault detection on, or things like that. And if you are going to go down that route of using haystack or brick or something, you do want to learn about that ontology and try to apply it kind of in a standard way that other people that would encounter your data, would understand it, right? So like when you look at haystack, this is also trying to illustrate some relations that would exist between things in a haystack situation, that you have a site and then you have a space, and the space has a relation to the site, and the equipment is related to the space it serves, and then the points are related to the equipment, right, that they're part of, and things like that. So there's a natural kind of order to things. So going back to this hierarchy, you can see that we can use elements here to go search for things that have a certain tag. Like, I want to find everything that's been identified as a floor in the building or space or something like that. And then I want to know, the children of that component that happen to be some kind of equipment, maybe, in this case, an air handler. And then we can, show points and things like that as well. But what I want to emphasize to you about this is that you don't have to have applied a haystack data model to do this, right? In this case, I can just look for things in my station, right? Under my driver network, under my lawn network, I have a bunch of device folders here that all represent my floors that have a graphic on them. So all I'm doing is looking for and these are implied tags that just exist automatically. You don't have to go apply a data model. So I just say, hey, I want to go find those device folders where the name of them starts with floor, right? And that's going to find my floors in the building. And this will have the PX view associated with it, right? Because that view's on there, right? And from there, I can just say, again, Niagara tags. I'm just looking at my child tag and looking for things that are named AHU something, and that's gonna show up my air handlers beneath that. And then I can just say, hey, I wanna see the child points under that piece of equipment, and there's all the points associated with it, right? So I could copy this into any station that, I might need to tweak it a little bit. Maybe it's a BACnet, folder instead of a lawn folder or something like that, right? But without me having to even do a whole lot of extra work, I could just put this on every job and it would build out dynamic navigation for me, right? I don't have to go build a nav file. It just reacts to what's there, okay? I'm sure, how many of you guys have set up history groupings before? Right? Okay. Pain in the butt, right? I shouldn't say that, but hey, things can be difficult a little bit, right? When you want to set up history groupings, you either use that metadata browser that historically has been slow, right? Or you go use the batch editor, and you're going to go, to your control points, to your history extensions, and you go add string slots to your history config, right? In this case, I've added some actual like N4 tags to these history config components. And I'll point out that really all these is a string slot that has the metadata slot flag set on it. So that's exactly the same thing that you do with the metadata browser, or that people did in AX building history groupings, okay? All you're doing is adding a string tag to it, right? And in this case, we have a namespace and a tag name, as opposed to it just being, a string, right? But you can build your history groupings out using these tags. So if I look at my history groupings in this case, I created a history grouping, and you can see that I grouped by my B: floor name tag and then my B: equip name tag. So you can use direct tags that you assign to the history configs to build your history groupings out. They can be the actual metadata tags that we were talking about here with Niagara 4 compared to AX. Now, one thing that a lot of people, is there's effort involved, right? I have to go put those tags on all these things, okay? So from an efficiency standpoint, if I was really trying to do that, I would probably use like a program object, for example. So I have a program object that would let me go look under the lawn network for, history config components here, and I could look for ones with, a specific parent name or something. and then I could tell it to add a tag, and this would use B format. Like I could say, %parent.name, and it's going to work out whatever that string is for the thing that it's adding a tag to. So that would be a way more efficient way if I wanted to go build out these history groupings using all these direct tags. But one of the downsides or things that people kind of complain about with history groupings is that we show the entire history ID when you look at them, right? So when I look at this grouping and you look at it, right, it has the building and the full history ID, right? And so some people kind of don't like that effect of it, okay? Well, when we look at our hierarchies that we made, right, then we can see that they're just grouping things by the floor, by the device, and showing the point and things like that, okay? So the idea here is that when you look at your history space, so if I just double click on the history space, I should be able to just drag this device out onto the web chart. Should be able to, right? This is always the fun with the live demos, right? And you see what it's done is it's added the histories that actually exist on the discharge air and the space temperature, and all the rest of the points. It's added them there, and they'll start plotting real-time values as the values change, even though they don't have histories on them, okay? So you can very easily give someone essentially history navigation here, history groupings, right? And even when you come into the web chart, you click on the add button here, instead of having to pick from the history space, you see all my navigation hierarchies are listed here as well. So and you can build these navigations out in different structures, right? And it allows people to more easily go find the things that they want to do reports on, right? Without having to dig through these huge long lists and things like that. So hierarchies have more value than just navigation, okay? Now, when we talk about system database, right, this is down in my JACE, and in the supervisor, we have something that's referred to as system database. And I'm not going to go into all the weeds here, but just understand that this system database is this orient graph database, and we have these indexers that will run, depending on how you configure them, but they'll run automatically or manually, and they go out and search those remote stations for things of interest, okay? So drivers, devices, device folders, points, things with histories, things with alarms, things with PX views, and that sort of thing. And it creates an index, a database at the supervisor that we can use then. Right, so that at that high level, the search service allows me to search for those things across the enterprise, and I can find all my air handlers, all my space temp points across multiple JACEs. I can build reports against all those as well. And when we look at the hierarchy up here, all we're doing is we're scoping this hierarchy against the system database instead of it being scoped against the station. So that allows us to build out an enterprise-wide hierarchy. So in this case, when I go look at my building nav, and I guess that was, I probably don't have time to get into the weeds on that one, so I'm just going to go into like the campus nav here. So in this case, we'll see that it's going to show me information from both my buildings. And building 200 is not even mapped into the supervisor, right? It's getting to that through building 100. That's that multi-tiered system database design. And these will then show me all the things that the system database knows about, and I'm able to just access these graphics by just double clicking on them, right? And I'm still in the supervisor station up here. I'm connected to my ControlsCon supervisor, okay? And all this is happening through virtuals, and the easy button there is just that you go into your Niagara network to the property sheet, and on the property sheet there's this virtual policies, and all you have to do is set the import virtual PX files on demand to true. So that eliminates having to go set up export tags and go add PX view tags to things in your remote station and do a join. All it does is on the fly when somebody, we have this hierarchy that's using the system database, and it's able to know about the things that it can reach through the virtual connection through the Niagara network. And then the station will just on demand, it will import the graphics and the images and everything and do it all with virtual ORDs for you. So you don't have to do the Niagara network proxy point engineering. You don't have to go through and set up PX view tags or point tags or do a join or things like that. So it's a much quicker, easier, less engineering labor way to set things up, okay? Trying to think what else I was wanting to talk about here. We talked about templates. We talked about the system database. NSpace would be the other thing. I got a couple of minutes left here, I think, unless Nicole's coming up with the cane to yank me off the stage. But I'm going to show you a PX file down here in my J station. And in this case, when I look at this label, and hopefully that's all readable there. I can do the, see if I get myself in trouble here. So when you look at the hyperlink here, what I'm using is NSpace : and then the path to the view in the station. And instead of using station : as that ORD binding, okay? And so what's gonna happen then is if I'm looking at a graphic in the building 100 station, so I'm connected to building 100 here. When I click on this link, it's going to take me to that graphic view in my building 100 station, okay? Now, if I'm looking at this same graphic, but I'm doing it from the supervisor, on mouse, battery must be dying. So if I'm in the supervisor, and I'm going to look at that remote station. I can get to it through the hierarchy, or I'm just looking at it through my virtuals here. If I'm looking at this slot path, you can see that I'm connected to my supervisor, right? This is my DNS of my supervisor, and then it's looking through the building 100 through the virtual gateway down to see this graphic in the remote station. And if I click this hyperlink then, which in the JACE took me to the alarm service in the JACE, you'll see now that it kept me in the supervisor and it just says NSpace here instead of station : But that's what does that special redirect. It keeps it, because I'm connected to the supervisor, it interprets NSpace as the supervisor. And it just does a substitution and keeps me in the supervisor, okay? So that can be very handy when you're doing these virtual graphics, is understanding how that NSpace ORD scheme works for you. All right, and just trying to think if there was anything else that we wanted to talk about, but I think that's about all I had to show today. So I'm probably wrapping up a minute or two early, which is probably fine, right, Nicole? So we'll get my brother from another mother that he's the better looking one, okay? That's what everybody says, so that's what he says anyway. So,
well, if I said it, it's true.
Okay, yeah, no arguing with that. All right, so I'm going to turn it over to Charles. And
before we do that, we do have a couple minutes for questions.
Okay, sure.
So are there any questions? We do have a mic runner. I have one as well. Ooh, are you guys going to be an easy group today?
I did a really good job, Nicole.
You did.
Explained it well.
It was very good. All right, well, I think you're getting off the hook. We will be bringing them all back up at the end, so if you do think of something you want to ask them, we can ask at the end too.
I forgot one thing here real fast.
Okay, you're good. You got time.
Get out of my VM here, so just if anybody's interested in it. All right. So there's a QR code there if you want. That's to a Dropbox folder that has the 3 stations that I was using to do the demonstration, and also a copy of the presentation as a PDF. So if you want that, that's and I'll share the PDF with Cochrane so they can send that out in case if you don't get the QR code. But.
Thank you. Hello. Thank you. Appreciate it. No questions for James? Oh man, you're getting lucky today. All right, thank you.
All right, thank you guys.
Right.